The Fermi Paradox tries to explain where the aliens are. People think that aliens have already been to Earth because our solar system is only about 4.5 billion years old compared to the rest of the universe, which is 13.8 billion years old. They also think that space travel might be easy to do if given enough time. The paradox is named after Enrico Fermi, a scientist who won the Nobel Prize and is said to have said the things above during a casual lunch in 1950. Since then, astrobiologists and other experts have been left scratching their heads about what it all means. In an explanation of the Fermi Paradox, the Search for Extraterrestrial Intelligence, SETI Institute in Mountain View, California, said, Fermi understood that any civilization with a modest amount of rocket technology and an immodest amount of imperial incentive could quickly colonize the whole galaxy. It would only take a few tens of millions of years for power to take over every star system. For a job to take tens of millions of years, that seems like a long time, but the age of the galaxy is about 1,000 times longer. Fermi died in 1954, so other people, like Michael Hart, looked into and explained the idea. In 1975, Hart wrote a paper called An Explanation for the Absence of Extraterrestrials on Earth, for the Royal Astronomical Society, Ross, Quarterly Journal. Some say this is the first study of its kind to look into the Fermi Paradox, but that's hard to prove. Hart wrote in the abstract of the paper, "We observe that no intelligent beings from outer space are now present on Earth." The idea that there aren't any other advanced civilizations in our galaxy is thought to be the best way to explain this fact. He did say, though, that more study was needed in biochemistry, how planets form, and their atmospheres to get a better idea of the answer. Hart said that smart aliens could have already been to Earth at some point in the past unless they started their trip less than 2 million years ago. He thought that it was most likely because there weren't any intelligent aliens that people were seeing. However, he also gave 4 other possible reasons. Because of a physical problem that makes space travel infeasible, aliens never came here. This problem could be in science, biology, or engineering. Aliens just chose not to come here. Aliens haven't been able to reach Earth yet because advanced society there didn't exist long ago. Aliens have been to Earth before, but we haven't seen them. In 1980, Frank Tipler, a physics professor at Tulane University, wrote a paper called Extraterrestrial Intelligent Beings Do Not Exist, which was similar to Hart's case but went further. A big part of his work was about how to get resources for traveling between stars. He suggested that this could be done by having some kind of artificial intelligence move from star system to star system, making copies of itself as it went. Tipler said that we are probably the only intelligent beings in the universe because proof of such powerful machines has never been found on Earth. In the 1980 paper, he also said that people who believe in extraterrestrial intelligence are like people who believe in UFOs because they both think that some miraculous interstellar intervention is going to save us from ourselves. Extraterrestrial intelligence is a popular topic these days, and every year, a lot of papers come out on it from different study groups. The exoplanet revolution has also helped the thought that there may be advanced civilizations beyond Earth. The universe is very big and very old. Different telescopes have collected information that the universe we can see is about 92 billion light-years big and is expanding at a very fast rate. Different tests show that it is about 13.82 billion years old. Aliens have had a lot of time to form and spread, but they probably have to travel a very long way to get to us. It was thought that there were no worlds outside of our solar system when Fermi said his famous statement. But in 1992, scientists saw planets going around a pulsar, which is a super-dense star corpse. After a few years, it was proven that there was the first exoplanet orbiting a star like the Sun. More than 5,000 exoplanets have been found so far, and each year more are discovered. There may be a lot of life in the universe because there are so many alien places. Over time, as telescopes get better, scientists will be able to look into the chemicals that are in the atmospheres of some close exoplanets. Nearby is a relative term, though. Proxima b, the nearest known star, is 4.2 light-years away, which is about 25 trillion miles, 40 trillion kilometers. The end goal is to find out how often rocky planets form in the habitable zone of their parent stars. The habitable zone is usually described as the range of orbital distances where water can exist on the surface of a planet. But water isn't the only thing that makes a place habitable. Other things must also be taken into account, like how active the mother star is and what the planet's atmosphere is made of. There are other reasons why the standard definition of the habitable zone is seen as too simple more and more. Icy moons in our own solar system, like Europa on Jupiter and Enceladus on Saturn, are far outside the livable zone, but they may still have life in the seas below them. Even with these caveats, it looks like there is a lot of living space out there. One study from November 2013 that used data from NASA's Kepler Space Telescope found that 1 out of every 5 Sun-like stars has a planet about the size of Earth orbiting in the habitable zone. A few months later, Kepler scientists shared a planet bonanza with 715 new worlds they had found. A new method called verification by multiplicity, which is based in part on the logic of probability, was used to prove a lot of these planets. When something crosses a star's face or pulls on it gravitationally, it's probably a planet and not a companion star. This is because a companion star close by would probably make the whole system unstable over time. Sun-like stars are the minority in our galaxy, though. About 3/4 super-dense made of the stars in the Milky Way are red dwarfs, which are small, dim burners. Astronomers have found several rocky worlds circling red dwarfs in the habitable zone. These include Proxima b and 3 planets in the TRAPPIST-1 system, which is 39 light-years from Earth and is home to a total of 7 rocky worlds. But it's not clear how livable these planets are because red dwarfs change a lot, especially when they are young. So, stellar eruptions could quickly destroy the early atmospheres of young red dwarf planets in the habitable zone, making it very hard for life to start growing there. Scientists say that we need to learn more about these stars and how life can be around them. They are getting more tools to help them do this kind of work. For instance, NASA's Transiting Exoplanet Survey Satellite, TESS, safely launched in April 2018 and quickly took over from Kepler, which was shut down at the end of that year. The highly anticipated, $10 billion James Webb Space Telescope from the agency is set to launch in December 2021. Among other things, it will look for possible biosignature gases in the air of close exoplanets. The PLATO, Planetary Transits and Oscillations of Stars, project from the European Space Agency is set to begin in 2026. The extremely large telescope, the Giant Magellan Telescope, and the 30-meter telescope are 3 huge ground-based observatories that will be online later this decade. They will be strong enough to smell the air on other planets. Breakthrough Starshot is a very big project that wants to use groups of tiny, laser-sailing nanoprobes to study Proxima b and other nearby worlds up close. If progress is made in technology, the first interstellar computer could take off around the year 2050. Astrobiology is still a fairly new field of study, but these missions and instruments will help experts learn more about it. We don't even know if there are worlds that can support life right here in our neighborhood. Studies on Earth have shown that bacteria can live in harsh conditions. This means that there may be microbes on Mars, Europa, Enceladus, and/or Titan, the largest moon of Saturn. We haven't looked into any of those places enough to be sure, though. That being said, the Fermi Paradox is looking at a lot more than bacteria. It's important to know how often life evolves on other planets and how often it wants to talk to other intelligent lifeforms or go sailing through the stars in order to answer the puzzle. If you have come to an end of this video, then please don't forget to subscribe to the channel and like and share the video to help us to spread the knowledge worldwide. Thanks.